Okay, in this video I'm going to show you how to model stress concentration in a bracket like this. I did similar video in ANSYS APDL, but this time I want to use this, use the Workbench, model the same thing in Workbench and to find the stress concentration. Okay, so look at the dimensions here. So we open Workbench application. Alright, so then now I make it zoom. Alright, Workbench has many solvers, but the one we're gonna use is this one, static structural. Right click and we have this, so we have to complete all these parts in order to to have a analysis and modeling. Okay, so as you see here, engineering data is we have a check mark there. ANSYS Workbench by default is going to use structural steel as default material. As long as you're interested in only in stresses, it doesn't matter really what material you use, but for this model I know my bracket is made of aluminum, so I'm gonna come here, see general materials, and then aluminum alloy. I'm gonna make it active. So now aluminum is gonna be one of the materials that we have in ANSYS, inside my model to pick. Alright, so then next step, I'm gonna do the geometry. I go right click, I'm gonna use a space claim here. So let's go and to a space claim and model that. Alright. So the modeling is open, modeling environment. So that bracket is like a rectangle. I'm gonna start from, oh, by the way, before starting I need to change my unit system to American system. So I come here, file, space claim, and then go to units, change this to imperial. Okay, that. Alright, so now I have it. So the width is 2.5 and the length is 10. So we have that rectangle, and then we had two holes, right? We had one here. The diameter there was, I believe, was 0.5. Yeah, I had another one here, 0.5. But let me right click and make it zoom extend. You gotta make sure that those two holes are at the center in the right spot. So I come here, say this from this must be, right now is 1.35, 375, so I need to make it 1.25. And same thing here, so this guy from this edge 1.25. Alright, so what else? I had another hole around the center here. That one, the geometry was, let's double check, it's 0.7. So 0.7 is right. You gotta make sure that one is at the center too. Oh, I'm sorry. So from hell to here. 1.25. Okay, what else? From center of this hole to center of this hole, the distance is 3.4 plus. I use 0.5 for these two holes because those two holes are gonna be used for loading. It doesn't really matter. So I use 0.5 for both. The distance between them is from center of this hole to center of this hole is 3.4 plus 0.5 divided by 2, which is 0.25, and then 0.7 divided by 2, which is 0.35. So it's gonna be what, 2.5, 0.25 and 0.35 will be what, 0.6 plus 3.4, it's gonna give me 4. Alright, from that hole to this hole, must be 4. Alright, so by the way, let's look at it. From this hole to the edge, I have 0.75, but I have 2.5, so will be 1 inches. So 1 inch from this edge to the center of this hole right now is 0.5, but I'm gonna make it 1. Alright, same thing on the other side. So from here to this is 0.75. I gotta change that to 1. Alright, sounds like we have the bracket ready. Alright, so next step is for us to extrude this, or in other words, give thickness to this. So how I'm gonna do that, I'm gonna go to pooling, and Workbench uses pooling, and then I click on the face, click on it and then hold it, drag it. When you pull it up, then you have to say the thickness is 2.44, then enter. Now I have the thickness given to my model. Alright, so alright, now what you're gonna do is you're gonna close this. As I close this, you see the check mark appears next to geometry. That means the geometry is done. So I'm gonna do right click, go to model, and then over there we're gonna do our loading and everything else, boundary conditions, meshing, and so on. Alright, so it's this coming up. Alright, so the model is here. So right now, as you see, there is no meshing. That's why you have here a yellow lightning icon. There, if I right click there and I say generate mesh, it's gonna make a coarse mesh. Alrighty, so we have it. Now let me apply boundary condition or fix it. So I'm gonna put fix support on this face, and on the other face I'm gonna actually not fix support, insert a force. So for vector you gotta do component. Okay, so I'm gonna apply a force to that face. As you see, I'm gonna define based on components. In X direction is gonna be, okay, I wanna have like good numbers. So let's see, stress concentration, not gonna really depend on how much load you have, but okay, my area is 2.44 is the thickness, times 2.5 is the width, right? Okay, so here is the area. So if I put 61 pound of force divided by 61, my stress is gonna come at 100. Okay, so I'm gonna do that. So to change the load unit right now is the inch, pound, and right pound force. Okay, so I'm gonna apply force in x direction equal to 61. Now this should give me a stress of, let's solve it. Stress of 100 psi far from the hole and around the hole. From my other video, we know that the stress is gonna be like 3.38, something like that, times of what we have a stress here. Alright, so I always look at deformation first. You can the deformation, total deformation, to make sure that my boundary condition applied right. So right, so then you can do animation here. I want to make sure that there is no bending involved here. That makes sense. Alright, then I'm gonna do a stress. Insert stress and normal x direction. Let's see this. Okay, stress here is 99, 98, 100, something like 100 as expected, right? We have some inconsistency because the mesh is big, and that's the reason. So I'm gonna do box zooming around the hole, see how much stresses are there. Yeah, it's 2.67, which is not good, right? We need to refine the mesh and see what happens. So if I do insert, this is how we can do that. Insert, refining the mesh, and then when here you can say I want to pick everything. I want to select all, then say yes, 9 faces were picked. I'm doing refinement level 1, so let's see what happens. Okay, now let's look at the stress. Yeah, improved a lot. Now stress concentration is 3.2, almost 3.15. So let's do refinement level 2, see how much stresses are gonna change. Alright, so now let's probe it now. As it went up a little bit, right? So you can do refinement level 3. So remember, I'm refining this on everything, right? Okay, so now we found 3.3. The largest I see here was 3.34. So it's close. 3.34 is my stress concentration. Yeah, but we can keep refining this technique, which is automatic and on all faces. That's we cannot go higher than that. But what else we can do is I can right click and insert, and this time I apply refinement only on that face, only on this face. And let's do refinement level 3. See if we get finer mesh. Let's see what happens. No, it didn't improve. So this is the best we can get with this approach, this refinement algorithm. Another way to refine, I'm going to use this way. Insert, you see the sizing? I'm going to pick this face. Look, the default sizing is 0.5 inches. I'm going to change that to 0.1. So let's like 5 times finer on that face. So let's see how it works. if we get finer mesh now this time. Yeah, this time you see it got much better. And I'm gonna solve it. Now we should have a more consistent result here around the hole. So you see it's very close to what we had from Workbench. Yeah, let me see if I can, if it let me go even lower. So if I go 0.0, like 2 times more finer, let's see if the results change at all. You know, this is called convergence analysis. We keep doing this until we see that the results get converged to a certain number. So you see it's a lot finer right now. Look, the result is no more. See, the third significant figure is changing. It's far more consistent. So we can stop here. So you can also move to the other side. You know, look at the other side of the hole. Yeah, here. And see the result there. You see it's very consistent. Alright, so alright, what we're gonna do now is I'm gonna use path technique to and show you guys the stress variation along the path that passing that hole. Alright, so let's see if we can go back to our original view, isometric. Yeah, okay, so this is isometric view. Now I'm going to define a path. So how do I do that here? You go here, insert, you see here construction geometry, and then you go path. You're going to define a path. Right now the path goes on that edge. I'm going to use 2 points to define my path and on the global coordinate. I use global coordinate, and you see the number of sampling points is right now 47. If you like, you can increase that. That's gonna give us better resolution for the data that comes out. Alright, so starting point is 0, but I want to have it on the hole. The hole was 5 inches, right? And then the end of it is going to be 5 inches too. So right there is like 5 inches, and then that path should go past my hole. The width of the hole was 2.5, so from Z0 to 2.5. Alright, so right now it's in the bottom, but I want to go do it from the middle of the hole, so it's 0.122. You remember the thickness was 0.244, so alright. So now I have the path in the right spot. Alright, so what I'm gonna do, I'm gonna now right click here and say we define that path. So I'm gonna say I'm gonna do a stress, normal stress. This time when it comes to geometry, I'm gonna pick the path and I say I just have one path, but we could have a name for it. I'm gonna have plot the stress along the path in X direction. So you can also name this result here. You see, you can come here, say sigma X, right? So right click, evaluate. Now you see the stress, you know, along the path. The data is going to be here. If I open it up, you see this is how stress varies. Goes from, the data by the way is in table. the lowest stress I have on the edge is 89, and then goes all the way up to 315, and then after that on the other side you have 317. Yeah, it's a slightly different is because of discretization. Okay, and the other end you should have it 92. So if you guys like, you can also export this data by like picking both columns, or export it to Excel. Let me do it into Excel. Yeah, so let me go here. I open it using Excel. Oh, okay, I have to, the way we opened it is not right because yeah, these are the stresses. Okay, so the max stress, you can come here and see the max. You see the max is max stress is 317. Average is how much? Average was 139.5. So stress concentration is going to be this divided by this. So this is 317. So what I'm getting is 2.27, 2.3 almost. Right? So yeah, this is how you can export the results here. Yeah, so let's look at the top view. Let's see if you can look at the top view. I want to make sure my eyeball it and see if the path is right at the center. Yeah, looks like it. Right, so yeah, so this is how you guys can do paths. See, go back to our isometric view here. Yeah, this was the mesh. Yeah, I want to do another technique to refine my mesh. You know, I can do is delete this, can delete this, go back to our original mesh, the coarse one. You can do that sizing on the entire thing. So right click, sizing, and then element size, as I said, right now default size is 0.5. You can do it 0.05 on the entire thing. But let's see how much I'm gonna get. You know how refined the mesh is gonna get. Is gonna uniformly refine everywhere. I wanna see how much effect it's gonna have on the results. Technically, refinement around the hole matters the most. So, alright. So it's working harder now because we have a lot of mesh. We're gonna have a lot of mesh. Yeah, you see the mesh. But the good thing now is uniform. So if I zoom it, if I box zoom it, it's more uniform. Around the hole, it had some difficulty. Couldn't do uniformly. So to in order to fit the contour, that complex curve, it had some of our elements got distorted, but it's pretty much uniform. So now you look at the results. I want to see our maxes, how much it changed. Yeah, so 320. This time is very consistent on both sides. 320.47, 320.48. If you recall, in my APDL modeling, I just model 1/8 of this bracket, and I found the stress concentration like that. Right, so the stress distribution, stress concentration is gonna be a little bit function of this thickness. If this bracket is too thick around the center where my path is, we're gonna have like plane strain condition. Not on this side, not on the hole, but inside, internally. But if it is thin, we're gonna have plane stress condition. In my APDL, I didn't consider this. So I mean, my path wasn't at the center thickness; it was on the face. So if you do it on face, we're gonna have a little bit of change, a little bit of difference. So if I wanna, okay, we can look at that, see what happens. So this was path. Let's name it path centered. But if I do another one, another path, this time I want to do it on the face. See how much the stresses are gonna change. Okay, so 5. This one is gonna be 5. Same thing. For this, I'm gonna have it 0.244 because the thickness was 0.244. So go from 0 on the other side. I'm gonna do what, 5. .244, and this one negative 2.5. Alright, so now you see it's on the top face. So let's plot the stress on that top face too, see how much the stresses are going to change. Stresses are going to change a little bit because on the top face you have plane stress condition everywhere along the path, but around the, in the mid thickness, when you are inside, you don't have plane stress condition. You have more like something between plane stress and plane strain, because this is not that thick. If it was too thick, I was gonna say inside, internally here, around here, you're gonna have plane strain condition. So, but at the hole, right at the hole, we have plane stress condition. But let's see how much difference we're gonna get here. All right, so remember the mid plane, the max was, let me look at it again just to remind you, 320.47 on the top face. Oh, I forgot to do the path. Okay, so insert stress normal. Okay, so I'm gonna do path. This time we're gonna path on the face. Okay, now let's look at it. So 320 was on that. Let's see how much you got here. It got lower. 295. Okay, so stress there is 295. Yeah, alright, so this is so what we found. So let me zoom it. Alright, so box zooming. I want to go and move along the path from top to down, see how much the stress changes there. So if I go here, you see, yeah, that one is kind of strange. It looks like the path starts a little bit after. Yeah, I'm a bit, I feel like this path is not okay. Let's look at the location. Yeah, let me change that path a little bit. See if it can let me, it will let me do that. If I do instead of, I feel like, no, it doesn't let me change it. Yeah, I want to go a little bit under the surface. Let me delete this. I went a little bit under surface, see what happens. So insert, geometry selection, I'm gonna go path, and yeah, increase a little bit. So you could have a path actually downward and see the stress variation in that direction. Anyway, so the purpose of this video was to show you like introduction to Workbench, how to model like a bracket, a 3D simple geometry, and also define a path and see how we could use that feature to our own advantage. Okay, to our own advantage. Okay, so this is what it is, you know, and I showed you guys also how to do refinement, you know, different ways of doing it, and how that affects our results. Alright, so I hope you guys find this video useful.